Okay, everyone, so another video. We've already completed both sections of 6.2 and we completed 6.3. So now we've got to do 6.1. That'll be one video, and then we'll do 6.4 in another video, and then we'll be done with chapter 6. So let's scroll down to 6.1. Okay, here we are, 6.1a, inverse trig functions. So the phrase sine -1x or arcsine is read as the angle whose sine is x. So normally in trig we say, oh, sine of 60 is square root 3 over 2. Now we'll be working backwards, just like we were doing in the other sections. We're going to be talking about trying to find the angle that makes sine be 1/2. It just looks a little different setup. It is understood that only quadrant 1 angles will be given when working with positive values of x for these questions. Use this definition to determine the following. The calculator can be used on problem 5 and problem 6 with a little star. Okay, so starting off with sine inverse of 1/2, draw me a picture. I would say if you've noticed on these videos, I draw this picture or some variation of this picture a lot. Probably get used to drawing it. You're going to be using it quite often. All right, we are looking at opposite being 1 and the hypotenuse being 2. What angle creates sine of 1/2? We know, because we've done this so many times already, that this is 30 degrees. Or if we're talking about it in radian form, we're talking about pi over 6. So either one of these would be acceptable for number 1. Just make sure that you follow what they ask for, whether they ask it in degree or they ask it in radian form. Number 2, I'm going to do over here. So we'll make sure there's number 1, here's number 2. So cosine inverse of square root 2 over 2. Well, this one's a pretty simple one, yet again. We've dealt with this one a lot. The only time that we have root 2 is if we have this picture. One of the other special triangles, we know if it's 1, 1, root 2, that this theta has to be 45 degrees or pi over 4 if we're talking about radians. Number 3, we're talking about tangent. So with tangent being 1, yet again we know that that can only happen with a 1, 1, root 2 triangle, which means that theta, yet again, has to either be 45 degrees or if we're talking about radians, has to be pi over 4. Now another way to write this, as you saw up here, instead of sine inverse or tangent inverse, we can say arc whatever. So this is going to be arc cotangent. Okay, and the only triangle that has square root 3 in it is our 30, 60, 90. But let's remember that cotangent always is adjacent over opposite, which means that the adjacent to this has to be root 3 and the opposite has to be 1 because the hypotenuse is always 2. What angle is across from 1 in a 30, 60, 90 triangle? Well, that's the 30-degree angle. Or, if we're talking about radians, we're talking about pi over 6. So 5 and 6 are just type in your calculator. So I'm going to type this one in my calculator right now for you. So all you have to do is you do your second button, and then you push sine, and that's going to give you your sine inverse, and then you type in the decimal. Make sure that your calculator is in radian mode because this is in radians. So 0.1247. That gives me a side or an angle of 0.125 radians. Okay, and they wouldn't ask you to put these in degrees, but just so you see the difference in the degree, I'm going to change mine to degree mode and copy the question, and I get an angle of 7.16 degrees. Arcsecant. Now, arcsecant, the way we're going to work that is we're actually going to use the cosine of -1. Okay, we're going to do arc cosine, but inside the parenthesis, I'm going to do 1 over theta. Or 1 over, not theta, sorry, we're finding theta, 1 over x. So this is going to be our x. We're going to do 1 over x and do cosine inverse. Yet again, you're going to do second, but this time hit the cosine button. So I'm going to have cosine of -1, and I'm going to do 1 over 4.3269. And my calculator is still set in degree mode, so in the degrees, it's going to be 76.64 degrees. Let me switch over to radian mode so we have them both. And in radians, I have 1.34 radians. That's number 6. Okay. These expressions are often written as equations and may be solved. So we can solve these. But yet again, we're doing the same thing. We're trying to find where arc cosine or cosine, what angle would make cosine be √3/2. Well, we're thinking about cosine. Cosine is adjacent over hypotenuse. So if it's adjacent over hypotenuse, we're talking about this angle here. That means opposite of it is 1. And we're talking about solving in radians. Since we're solving in radians, it's going to be pi over 6. Now looking at number 2, secant -1, 1. Well, we know that if we're talking about secant, that means we're also talking about cosine. Secant is 1 over cosine, and so we need to know, when is secant 1? Well, another way to look at this is that cosine is x over r. That means that secant is r over x. We know that r is always going to be 1. As long as we make it link the unit circle, it's always going to be 1. So I need to know when x is 1. Well, there's only one spot for this to happen, and that's right here at 0.10, quadrantal angle, 0 degrees, or 0 radians. On the same idea, since we're talking about it, number 2 and number 3 have the same answer, because now we're talking about when is cosine 1, but in degrees, still 0. Same picture. And then number 4, with arc tangent being 1. So arc tangent, we know if it's going to be 1, that means we're talking about the 1, 1, √2 triangle. Opposite of this is always 45 degrees, therefore in degrees it's going to be 45. If we're talking about radians, this will be pi over 4. All right, part B, but what if we talk about negative values? Notice that all these have been positive up until this point, but what if we switch it over to negatives? Since we need the angle whose tangent is -1, since we're talking about tangent being -1, would the solution be 135 or 315? Or any of the angles coterminal with these? To answer these questions, we make the following agreements. So you need to make sure that you pay close attention to these, write them down, or keep this note sheet handy somewhere whenever you go to use your test, because these are going to be important. If we're going to be talking about sine, then it's going to be between -90 and 90. I'm going to go ahead and write the radians above it just so we have them. We're talking about negative pi over 2 to pi over 2. If we're talking about cosine or secant, then it's going to be 0 to 180 or 0 to pi. If we talk about tangent, it's going to be between -90 and 90, so negative pi over 2 to pi over 2. And if we talk about cotangent, it's going to be 0 to 180 or 0 to pi. The other thing we have an agreement on are the following down here, that if we're doing sine inverse of a negative number, we're going to be talking about quadrant 4. Cosecant, same thing, quadrant 4. Cosine and secant, if we do a negative, they're both going to be quadrant 2. Tangent, a negative tangent will be quadrant 4, and cotangent will be quadrant 2. Verify this by calculating the following on your calculator. Now, I'm going to go ahead and do these real quick. Your calculator is going to pop out the following values if you do these. Sine inverse of -0.5. And I'm going to change mine to degree mode. Pops out -30 degrees. If I talk about cosine, I get 120 degrees, which is quadrant 2. Tangent, you get -45 degrees, which is quadrant 4. Cosecant, now when we type in cosecant, remember we have to do sine inverse 1 over x. So I'm going to type in sine inverse 1 divided by -2. And I get -30 degrees. Secant, same thing. It's going to be cosine -1 over x, which is going to pop out 120 degrees. Cotangent -1 is going to be tangent inverse 1 over x. As long as we're following the pattern that we've been using. But that says -45 degrees. Now I want to show you, pull up Desmos. If I type in cotangent, I'm going to use a keyboard, functions, I want cotangent of x, and then I want y is equal to -1. Well, look at there, it doesn't cross. But I also want to check in their calculator. What if I type in -1 here? That gives me 2.35. because really what we're looking at is this here. Notice it also says 3 pi over 4. Well, 3 pi over 4 is not negative 45 degrees. So what we have to do in terms of cotangent, pull up this again, what we have to do in terms of cotangent, it's not this, but we do tangent inverse. So whatever tangent inverse is, and we add pi. Okay, so we do tangent inverse like we normally were doing. That's how we got the negative 45, but we add pi to it. Therefore, we do this because it's going to move, it's going to do a phase shift where the cotangent and tangent would be. Okay, so this answer is not negative 45. We now know based on Desmos and by using this little formula. I'll show you real quick. Negative 45 plus pi would be 180. That gives me 135. Verified twice. This is 135 degrees, and that is second quadrant. All right, some practice on how to solve. Solve the following. The calculator may be used with 4, 5, and 6. And then down here, part C, we're going to draw pictures in order to help evaluate those. Okay, starting up here. Solve in terms of radians. I don't think we need a lot of practice on this because I think you guys get the idea of what we're doing. We're just doing the same thing over and over. So, tangent negative 1 is negative root 3. You can really type this in your calculator. No one's going to be the wiser. But tangent negative 1 in negative root 3, that's going to be negative pi over 3. Arc cosine, it's going to be 135. Notice this column's radians, this column's degrees. Arc sine negative 1, that's negative pi over 2. Arc cosine of this number, so let me type that in real quick. Negative 0.2371 comes out to be 103.72 degrees. All right, cotangent, remember that cotangent we have to do, since it's negative, we do have to do the tangent negative 1 divided by that number. So negative 2.4768. And then we add 180 degrees. So this is 158.01 degrees. And last one in radians. Switch my calculator over. We're going to do cosine inverse. 1 divided by this number. We get in radians 1.99 radians. Okay. Moving down, combinations. All right, let's look at number 1 in picture format. I'm talking about cosine negative 1 of u. Well, we know, we're talking about this angle theta here. If we're talking about cosine of u is the side of the triangle, the ratio of the sides. Well, cosine is adjacent over hypotenuse, which means that this would have to be the letter u, and the hypotenuse would have to be the number 1 for this to be u over 1, which would give me u. Sine, however, is going to be doing opposite over hypotenuse. I do not know what this side over here is, but I can find it using Pythagorean theorem. because this is supposed to be a 90-degree triangle. So we do a squared plus b squared equals c squared. We know that a is u. We don't know b squared. And we know c is 1. So if u squared plus b squared equals 1, and I solve for b squared, so I subtract u squared, and then I take the square root. So b is square root of 1 minus u squared. Now it is plus minus, but in this particular case, we're talking about u being a positive number, therefore we're going to talk about first quadrant. So this is 1 minus u squared. Now that I know this is done, I've already done it, now I just need to do sine of that theta here. Well, sine of theta is opposite over hypotenuse. 1 minus u squared divided by 1, which is just the root of 1 minus u squared. And there's my answer. These three questions are very algebraic, so you need to make sure you pay close attention to your algebra and try to think a little in the abstract. Number 2, same thing. We're going to draw a picture. We'll still be talking about first quadrant. Here's our theta. Now we're talking about secant of u and 3. Well, secant is hypotenuse over the adjacent. So hypotenuse is u this time, and the adjacent is the number 3. Pythagorean theorem again. So I know that I have a 3 squared plus a b squared equals a u squared. So b squared is equal to u squared minus 9. So b is equal to the root of u squared minus 9. All right, now I want the tangent. Tangent is opposite over the adjacent. So I have u squared minus 9 over 3. All right, this is the part where you pause the video and try this last problem out. Okay, hopefully you paused the video, worked out the problem, and are here to see the answer. So, really quickly, can't seem to draw a straight line today. There we go, it's a little bit better. Not straight, but better. Here's my triangle. Here's my theta. We're talking about cosine, so I know this is u, this is 1, and since we've already done this picture, this is 1 minus u squared, because we did this same picture right here. So now that I know that, I want tangent, which is going to be opposite over adjacent. So it's the root of 1 minus u squared, all of that divided by u. Now we can talk about 6.1b, which is inverse trig functions again. We're going to be doing the same thing we were doing at the end of the 6.1a. We're going to be starting with these problems. So, starting with number 1, cosine of sine. All right, I'm looking at sine, and it says that sine -1 is -3/5. Now remember, this is where that stuff from the last section come into play, is that where is sine -1 or -3/5? Sine being negative is down here, quadrant 4. and opposite of that, -3, and my hypotenuse is 5, which tells me that this is the number 4. Now you can solve that with the Pythagorean theorem. I'm not going to go through that, but we all know, since we've seen it several times in this class, that 3, 4, 5 is one of those Pythagorean triples. So now that I've done this, I just need to do cosine of this theta, which is 4/5 adjacent over hypotenuse. Going through number 2, cosine -1 is 1/2. Well, talking about 1/2, that's a positive, therefore we're talking about first quadrant. And 1/2 is 1 and 2. Now we know this setup as well. This means this is square root 3 because it's a 30, 60, 90 or 1 square root 3, 2 triangle. So I've done this part. Now I just need to do sine of the theta. Well, it's root 3/2. Opposite hypotenuse. Number 3. Sine 2/5. Since it says 2/5, we know it's first quadrant, it's positive. There's 2, there's 5. Yet again, you can work out Pythagorean theorem. I'm just going to go ahead and write it up here. It's 21. Now that I've done that, I need cosine of the theta. Well, it's be root 21/5. Now, number 4 and number 5, notice they got the little asterisks, which means that you can plug them in your calculator. Remember, though, with cotangent, you have to compensate for the calculator error, which means you got to do this, tan -1, 1 over this, add pi, and then perform cosine. Okay, so I'm going to do tangent first. So I'm going to type in my calculator just like I see it. I'm going to do tangent of cosine -1 of 0.12767. And I come out with the number 7.77. That looks really odd. Let me write that back a little bit better. 7.77. Number 5, here's how I'm going to approach number 5. I'm going to do the cosine of tangent -1, 1 over -0.4123. I'm going to add pi. Okay, so this is going to be my setup for what I'm going to type in my calculator. This way it's going to do the cosine after it performs what's in here, tangent -1 of this, added pi to that angle, and then cosine of this entire angle. Okay, and I come out with -0.3811. Okay, looking down here, sometimes you can perform some shortcuts. Okay? For instance, with number 6, if I take the inverse of the original function, they cancel off, leaving me with just the angle. Because what are we really doing? If I found sine of pi over 6, that gives me some side measurement, and then I do the inverse of that side measurement, it's going to pop me back to the angle. Same thing here, cosine and cosine, cosine -1 and cosine are inverses, therefore they cancel off, leaving me just the angle. Notice they tell you no calculator because it's the same thing, sine of sine inverse. Therefore I'm left with 0.1234. Now it gets a little tricky when you have this, but all you have to remember is that these two are inverses regularly. So that means that whatever this is going to be flipped. Same thing here, these are regularly inverses of each other, so we flip it at the end. Now on these, they say there's tricks to these. I didn't really see the trick to these, other than that you can rewrite this one as tangent of tangent -1 over 0.12767 positive. We don't have to worry about doing a correction. So since these are opposites, or inverses, we just evaluate this, and we come out with 7.833, 1 divided by 0.12767. And then here we have to do the correction, which you've seen before, so I'm just going to go ahead and give you it's -2.43 is our answer. All right. Now to the actual important part. We only got 4 questions left. Is evaluate the expressions involving both trig functions and trig inverses. Apply sum and difference or double angle formulas. Okay. So here we are going to be doing sine of 2 sine -1 4/7. The way that I did this question was I'm looking at it in a picture idea. You can also do it that way like we've done before. I'm going to double whatever sine -1 4/7 is. But there is another way. 2 sine inverse, which means sine of 2 theta. Well, what do we know about sine 2 theta? It's 2 sine theta cosine theta. Now all I need to know is I need a picture for what theta actually is. What we know from this is that sine was 4/7. And using Pythagorean theorem, I can tell you that this is root 3. So now all I have to do is perform the sine and the cosine from theta, fill in the formula, multiply, and simplify. Well, we already know that the sine is 4/7. And now that we know all 3 parts of this triangle, we do know that the cosine is root 33 over 7. So now we multiply and simplify. So I'm going to multiply all my numerators, 2, 4, and root 33. That gives me 8 root 33. And on the bottom, 7 times 7 is 49. All right, here we're going to be talking about cosine of 2 theta, because this is 2 times some angle, so cosine of 2 theta. And cosine 2 theta is 2 cosine squared theta minus 1. That's using our one of our double angle formulas. Here's my picture. Sine was 4/7. And that means this is 33. So I need the cosine, which is root 33 over 7. 2 root 33 over 7 squared minus 1. So root 33 over 7 squared is 2 times 33 over 49 minus 1. And I'm going to change minus 1. I'm going to go ahead and change that to 49 49ths. That way I can combine after I do the multiplication. So I have 66, 2 times 33, 66 over 49, subtract 49 49ths. Just a quick application there, 66 minus 49, we're going to go with 17, 17 49ths. All right, well, number 3. Working, okay. So number 3, we've got to apply the sum or difference formulas. In this case, it's a sum formula. We need to apply cosine of s plus t, where this is s and this is t. Now, we've done problems similar to these in the past. It's just now it looks a little different. Now, I'm going to draw one. This is going to be the s graph. And over here is going to be the t graph. So for the s graph, I've got arc sine 3/5. Sine is 3 and then 5, which tells me this is a 3, 4, 5 triangle, Pythagorean triple. T over here, it says arc cosine, so we're talking about cosine 5, 13. So 5 and then 13. Well, that means this side has to be 12. 5, 12, 13 is also Pythagorean triple. Or you could solve a Pythagorean theorem if you need to. Now, when we do cosine st, remember it's cosine of s, cosine of t. Sine in the middle changes. And then we have sine of s, sine of t. Now, all this means is that I'm going to find the cosine of the s graph, multiply it by the cosine of the t graph, and then subtract, then do sine of the s graph times sine of the t graph. So whatever the letter is, that just corresponds to what graph we're going to use to find that particular ratio. So cosine s, so I'm looking at s, cosine from theta is 4, 5. Now I need cosine from the t graph. That's going to be 5 13ths. Minus sine from the s graph, 3/5. Sine from the t graph, 12 13ths. Okay, now we just multiply. 4 times 5 is 20. 5 times 13 is 65. Subtract. 3 times 12 is 36. 5 times 12 is, or 5 times 13 again is 65. Perform the subtraction, I get negative 16 65ths. So see, not a hard question. Took us a little less than 2 minutes to do the question. Just have to set out your graphs first and then do your sum formula. Okay. Over here with the tangent, we're doing a sum of tangent. Tangent of s plus t. Well, yet again, this one's s, this one's t. So I need an s graph. And luckily, for these two questions, the s graph looks just like the last one. 3, 5, and 4. Here's theta. And the t graph, where we've got 5, 13, which makes this one a 12. All right, and tangent of s plus t, I'm going to make us some room, is tangent of s plus tangent of t divided by 1 minus tangent of s tangent of t. Okay. Luckily, this time we only have to use these graphs once each, because whatever tangent is here, it's the same down here. Same thing for the t graph. So, tan of s, 3/4. And I need tangent t, looks like it's going to be 12/5. Okay, that means on the bottom I've got 1 minus 3/4. And then here, tangent of t was 12/5. Now I can work on simplifying that. First thing I'm going to do on the top is I'm going to make these into 20s. So I multiply by 5 on this one. So I've got 15, 20. And over here I multiply by 4, so I have 48 20s. Down here on the bottom, I'm going to go ahead and make this one, since these are going to multiply to make 20. It's going to be 36 20ths. I'm going to go ahead and make 1 and 20s, so 20 20s minus 36 20s. Go ahead and add these up. 15 and 48 is 63 20s divided by negative 16 20s. And since these both have the same denominator, they cancel out, which leaves me 63 negative 16ths. Okay, looks like that is the end of 6.1.